Welcome to Part 2 Competency 1 quiz. In this video, we will continue to work with scientific notation, real number system, and properties of real numbers. Number 7, Isabel multiplied 11 by 3, then multiplied that answer by 5. She decided to first multiply 3 by 5 to get 15. Then she multiplied 11 by 15 to get 165. Which one of the following conclusions is valid concerning the steps Isabel took to solve this problem? Okay, this is all in the English wording. So I'm going to take a look at that first, and then we can look at our ABCD options. Okay, so this is what they're saying. They're saying we have 11 multiplied to 3. Then multiply that answer to 5. Okay, she decided to first multiply 3 by 5. Okay, so 3 by 5. Okay, to get the 15. Okay, then she multiplied 11 by the 15. Now, this is really what's going on. 11 to the 15. Oh, let me not mix symbols there. That's not a good idea. So it's 11 multiplied to 15. So if we look at the English, the order of the numbers is not changed. Everything is multiplied. Okay. So we're not switching the position, but I use parentheses for each time they talked about multiplying something first. And we have the word first. Oops, I was going to highlight that. We have the word first being used. Let's look again at how it's used. She decided to first multiply 3 by 5. So that implication is that she switched from, she's changing order. She's going from doing this first to this first. When I had to read this a couple of times before I actually came up with this. Well, not a couple of times, but I had to really work through it. Okay, so if we look at the English exactly as is, okay, and because it's all multiplied together, order doesn't matter. I'm saying that she is correct, and I'm going to verify that by multiplying all those things together. And it doesn't matter which side of the equation you multiply, okay? So let's do the first one. So 11 times 3, parentheses, and then times 5. We get 165. So that is verified. So now let's look at our options. A says she is wrong. No, she's correct, actually. B, her answer is correct. Okay, I'm okay with that. And she used the commutative property of multiplication. Yes, I agree with multiplication. But did she switch numbers around? No. The word first tells us she changed order, not position of numbers. So I disagree with B. Let's look at C. Her answer is wrong. No, that's out. Her answer is correct, and we know that, and we've proven it with our calculator. D. Her answer is correct, and she used the associative property of multiplication. The word first matches with this property. Therefore, I agree with A. Okay? All right, let's look at number 8. Okay? The following 3 steps are applied to a number n. Okay, now here's our steps. So let's look at the question. How does the number appear after C? So when we're done with C, we need to come to our options and see what's valid. A says the number is squared. So we know we have n and we know it's squared. B, the result of part A is subtracted from 10. Okay, so that means you're going to have 10 minus that n squared. Okay, I agree with that. Okay, then C says the result of B is raised to the power of 1/2. Okay, yeah. You have to know your exponents and roots in order to see what that is. Okay, well, the first thing I'm going to do is eliminate something. Well, I don't like A because this plus, nope, we have the word subtract. We already know that I'm not believing that one. It's out. Uh, this didn't happen. It wasn't stated. Okay. So I'm not buying that. That's just not going to work for me. Okay. And the truth is, where I have that circled, that part actually just equals n, so that doesn't make sense. See? Okay, underneath the radical, I'm liking that. I believe that. Now let's look at D. That's not what the English wording says. That's not what A and B are telling us. So I'm not going to believe that. Well, now, once I go through my ABCD options and I look and all I have left is C, then some of you probably know, and if you didn't, yes, taking the square root of something is equivalent to taking the exponent of 1/2. Okay? So these things are equal and it is verified. It is correct. Okay, these two things are the same. And let me show that to you really quick. If we have x to the 1/2, this is what we have as a root. All square roots have an understood 2 here, and that is actually just x to the first power taking the square root of it. That is x to the 1/2 power. Okay? All right. So that means C is okay. All right. Let's move on to number 9. Number 9. What is the scientific notation for the number 51/2? Okay. Well, let's pop that fraction into the calculator and see what the decimal actually is. Okay. Set your fraction up and 51, arrow down. We have 2. Enter. Okay, remember, push the toggle button. Okay. So this actually equals, okay, 25.5. However, for this to be a valid scientific notation, I need to move one space and the decimal point needs to go after the 2. So let's look at our A, B, C, D. Okay, I agree with A. I like that. B, I do not agree with. C, I do not agree with. And D, I do not agree with. That was pretty simple. Okay, but let's take a look in the calculator what this is going to be. Also, we have one space that should mimic the exponent, and it does. So everything is pointing to option B. Okay, so let's put not option B, I'm sorry, option A. Let's put option A in the calculator, 2.55, and then push this wonderful scientific notation button and put 1 in for your exponent, press enter, and that's what we started with, but the decimal form. So how do we get the fraction form? Push toggle, and we're right back where we started from, so A has been verified. Let's look at number 10. Let's go over here. We'll look at 10 and 11. Okay, number 10. Which of the following is an integer but is not a natural number? Not a natural number. Okay, so if it's not a natural number and it's an integer, this means it has to be anything negative. And that's also the notation of Z negative, okay? Meaning we don't want anything positive, no ends, natural numbers, okay? All right, so let's take a look. So A, that's not even an integer, so that's out. So let's get rid of that guy. You're no good. Let's look at D. That's a decimal. That's out. Okay. And what did we say? We can't have anything positive. C's out, and we are left with B. And yes, that is a negative integer. That whole sentence just meant, hey, look over there and see which one's a negative integer. There you go, we're done. Okay, let's look at number 11. Which one of the following is irrational and lies within the interval of -3 to -2.7? Oh, and this looks very interesting. Okay, everything's negative. They're trying to fool us. Okay, let's look here. I can already see one that we can eliminate. C is obviously not going to work because that lies outside the interval. That is somewhere closer to 0 out in this realm here. Much closer to 0, somewhere over there. So that won't work. Okay, well, let's put some of these in the calculator. And we need to know what E is. And that's on our calculator. But before we do that, let's look at A. So we have negative, second, radical, 2. Okay, good. Let's push enter. And we need our toggle. Ooh, yeah, that is closer to 0, but a little bit less than C was. So that's over here. It's actually larger than the negative. It's less negative. Let me put it in that term. It's less negative than negative 2.7. So that's not it. That doesn't lie within. So let's mark that out. Okay, let's look at B. That is your E. Okay. Now we have an E button, but it's not like a super convenient E where you can just push it. Okay, so let's push negative. Okay. Now, how do we get that? Push second and the ln, which is for natural log. Okay, it sets us up. See the negative, but we have to put an exponent in. Well, we just want the E on its own. So just put in the 1, and that becomes the E on its own. Now, that is Euler's E, and it has actual decimal value. So let's push enter. Oh, goodness. And it is just a little teeny tiny bit more negative than the 2.7. It lies here. Let me erase this. It is gonna, I mean, seriously, if we had a number line, 0 is out here. I mean, we're just kind of like like going through the process here. Option C would have been here. And then go down a little bit more and you'd have A. And then over here, let's say we have the -2.7. And then down here, let's put 3. Now, you know my number line is not accurate. I'm just penciling these things in, literally. Okay, but for answering's sake, this would be the negative E just inside this nice interval that we're looking at here. Okay, which I'm going to say I'm believing E. Okay, but let's look at D. Negative, second, radical, put that 5 in there, push enter, toggle. Oh, goodness. That is just over here between our interval and A. Yeah, 2.3. Yes. So that would be just in here. So everything except for E is actually less than the values inside that interval. So there you go. Who knew? Euler's E, well, actually, negative E was what we wanted this go round. Okay. All right. This is the last question in this video. Thank you guys for watching. Again, I say it every time, it's appreciated. You're liking us and sharing us and subscribing. You guys are the best. Okay. And I really honestly do hope everyone passes their test. Again, happy testing, everybody.